For example, in this session, we are going to discuss whether the power is supplied or power is being absorbed by the circuit elements. Now, in our last session, we have discussed how to calculate the power. The power is given by the voltage times the current, or it's the product of voltage times current. Now, in this case, everything is given. We have to determine whether the power is absorbed or the power is being delivered. Now, how to differentiate whether the power is absorbed or power is being delivered? Now, if when you calculate voltage times current, and if you get negative, then we should understand that the power is supplied by that element, that circuit element. And then when you calculate, if you get positive sign, then we should understand that that particular element is absorbing the power from the that circuit or that network. Now, to get plus or the negative power, or to determine whether the power is being delivered or the power is being absorbed, we have to take care of the sign conventions. Now, first one is we have to take with the current here. Now, to give the sign conventions, we have to check with the current direction. In this case, this current I equal to 10 ampere is entering from minus to plus. So it is crossing from minus to plus. So in this case, we have to give your current is equal to negative. Now in this case, okay, you should also remember that here we have a dependent source in the network. So I think for the electrical, you may study in the circuit theory 1, but for the IT students, I think it's very new to you. So do not worry about this. This is the dependent source. So we have to treat this dependent source differently. This dependent source is also controlled by this branch current here, which means we have to multiply 0.4 times 10. Now this is the current. This is the amount of current that you have if you multiply it with the 10. Here you see this current source is controlled by this branch current here, which means you have to multiply 0.4 times I. Now to solve this one, I have written the network here. Now to calculate, okay, let's calculate let's calculate the P1. To calculate the P1, that I is entering from negative to plus. See, current direction, if you check this current direction, is going from here to here and there, and which means it's entering from negative to plus. So negative of 10 times the voltage here, the 30 volt. So we have 30 volt, which will get a negative, how much? 300 watt. And then similarly to calculate the P2. Now to calculate the P2, we have this current, the same current, okay, is entering from plus to minus. So we have to give plus 10 ampere times, okay, 10 volt. So which will be equal to how much? Okay, 100 watt plus 100 watt. And then to calculate the P3, we have to also calculate the P3. For this P3 in this branch, it is 14 ampere moving from plus to minus. So we have to give plus 14 times 20 volt. So which will get how much? 20 times 14. So it's it's 280. 280 watt. And then for P4 here in this branch P4, for P4 again here current is entering from minus to plus. So we have to give minus of 4 ampere times 8 volt, which will get negative 32 watt. And then similarly you can also calculate for the dependent branch there. P5 is equal to, here again, here also is plus and here's negative. And if you check in this direction, it's entering from negative to plus. So we have negative of 0.4 times this I, value of I is given by here. So we have 10 ampere times then the voltage at that source, that branch is equal to 12. So you have 40, okay, negative 48 watt. Now this is the power in each branch. In P1 is negative 200 watt, in P2 plus 100 watt, in P3 is 280 watt, and then at P4 it is minus 32 watt, and then P5 we have minus 48 watt, which means, so if the power are negative, we should understand that it is supplying the power in that network, and if it is plus, then you should also understand that that particular branch is absorbing the, or they're using the power from other branch. Now this is how we have calculated the power. Now the formula that I have used is P is equal to V times I, and then the current direction we're giving negative if current is entering from negative to positive, and then vice versa, which means we're giving positive if the current is entering from plus to minus. So I think in this way is better. I'm using this formula to calculate the power in each branch. Now how to validate your calculation? From the law of conservation of the energy, it says that the total power, P total, okay, P total, the summation of the, okay, let's write sum of power in all branch, sum of power in all branches will be equal to 0. Okay, let's do it. Let's do P1 plus P2 plus P3 plus P4 plus P5. If you sum this one, you should get 0. Okay, let's write. What's the value of P1? Minus 300 watt plus then P2 100 watt, then P3 plus 280 watt, then P4 is minus 32, and then again P5 is minus 48. So if we sum this one, okay, here we are having 380, okay, put it, okay, it's equal to 0. So we have verified that our calculations are correct. Now this is how we should be doing the power calculation in the network. First we have to multiply current and the voltage, and then to assign the sign of the current, it depends on the direction. Here current direction, we are giving negative if current is entering from negative to positive, or we are giving positive if it is entering from positive to negative. And then okay, again we have another example here in figure 1.28. Figure 1.28 shows a circuit with 5 elements. If P1 is equal to negative this many watt, P2 is also given, P4 is given, P5 is given. Calculate the power P3 received or delivered by element 10. Now we have to calculate the P3 in this. Now, as I said, the sum of power in this network should be equal to 0. So for this one, if you want to calculate P3, we have to make P3 as a subject, and then we have to sum up all this power you'll get, and then whatever the answer you get is the power for this one. Okay, let's do it with some example. Okay. Now okay, here we have, and then this is for second example for figure 1.28. Now P1 is how much? Is given negative 205 watt, then P2 is 60 watt. P3 we have to find the P3. P4 is 45 watt, and P5 is how much? Is equal to 30 watt. Now to get the power from the law of conservation of the energy, it says that P1 plus P2 plus P3 plus P4 plus P5 should be equal to 0. Now our unknown power here is P3, so we have to make P3 as a subject, which means negative of P1 plus P2 plus P4 plus P5, and then you can substitute the power there, the value of the power, which is negative of, for P1 is minus 205 plus, and then P2 how much is 60 watt plus 60 watt, and then P4 is plus 45 watt plus, again we have 30 watt. So this, the remaining answer of P3 is equal to how much? Negative of 205 plus 60 plus 45 plus 30 is equal to minus 70. Minus, okay, minus of minus 70 watt, so which is equal to 70 watt. Now your value for P3 is 70 watt. This is how we should be calculating the power in the network. Now you have this concept. Now, okay, let's go to next slide. Okay, the table gives the total load connected and operations in a bachelor quarter. Okay, now these are the data that is given from one of the bachelor quarter. Determine the total power and the energy consumed in 1 month. So it says that they are using the refrigerator, which is 780 watt rating. Then they're also using air conditioner, 1.5 ton. Now usually these air conditioners, the rating of air conditioners are given in the tons, which means it's 1500 watt. And then 40 watt fluorescent tube, and then it's also using incandescent lamp, which is rated 60 watt, and we have exhaust fan. And then here are the number of appliances: one refrigerator, one air conditioner, 3 fluorescent tube, and 60 watt incandescent lamp. Okay, number of 60 watt incandescent lamp is 2 numbers of exhaust fan. And then here are the operation hour. So let's calculate the power, total power and the energy consumed in a month. Okay, for this one, for the better understanding, I've used the Excel sheet. Now these are the given data in the slide. We have to calculate the power and the energy. Now to calculate the power, is simply is equal to this rating times the number of appliances. So similarly, you can also do for all the appliances, and then here, okay, let's write here total. The total power is equal to sum of so this many. Okay, let's write this one, the unit here in watt. The total power or the total connected load in that bachelor quarter is 2650 watt, 2650 watt, or 2.65 kilowatt. Now to calculate the energy in a month, okay, in the slide, okay, in the PPT, it says that the operations are, okay, this means hours per day, which means in a month we have 30 days, so we have to multiply everything with the 30. I hope you got the point. Here is given with the operations are given in hour per day, which means to calculate the energy in a month, we have to multiply with the 30 days. Okay, sorry. So I have to share this. Okay. Now to calculate the energy, the rating for this one, rating of the equipment or electrical appliances times number of operations times number of appliances connected in that room times 30. So we have, okay, this many energy is being consumed by the refrigerator in a month. And then again here we have air conditioner, which is similar. Okay, so for air conditioner again is operating only 1.5 hours a day, and then rating is 1500. Number of air conditioner in a room is 1, so we are having this much. Okay, I hope the calculation is correct. Okay, 30. This one also is 30. Okay, now this many energies. Okay, in the total, so sum of okay, now when you do like this, it's almost like 669.3 kilowatt hour. Now unit of the energy is kilowatt hour, and is per month. So we have calculated in a month. I hope you got the point how to calculate this one. To calculate the power is easy, right? We're just multiplying rating times the number of appliances. So in that room, the total connected load, we also call it as a total connected load. The rating is 2.65 kilowatt. And then to calculate the energy, it is rating times the number of operation, because when you say about the energy, there should be certain time period. So refrigerator is operating 24 hours, and then if the rating of the refrigerator is 780 watt, okay, the rating, this one is also in the watt. If the rating is in the watt, okay, we're calculating everything in the watt, and then at the end we have this many energy consumed in a month. So if you want to calculate the cost of this energy, the cost of energy, then we, okay, let's say in our country, if the cost of energy is in term 2.67 per kilowatt hour, then we have to multiply it with this one. I hope you got the point. Okay, this is how we should calculate the energy and the power. Now, these ratings are as per the specification that's given in the appliances, but in a real case, like it may not consume this many amount of energy. Or like for refrigerator, if it's rated 780 watt, while it is in operation, it may not consume this many. This is the maximum energy that it can consume. This is how that ratings are given.